In homework question 3A, my money making class, question 1, we're going to calculate some prices of bonds using time value of money. And we're going to use Excel because Excel's got a really cool time value of money system of functions. And the reason why I like it is because, for example, if you type equal rate and then a parenthesis, then the inputs to this are number of periods, the payment per period, the present value, the future value, and then the type, whether it's at the beginning of the month or end of the month. So that's kind of cool. Now the really cool thing is, if I would have typed equal NPER instead. Let me show you. If I would have typed equal NPER instead here, the reason why I like this so much is because if I type this instead, I get the number of periods function, which has inputs rate, payment, present value, future value. Or if I had typed present value, then the inputs to present value are rate, number of periods, payment, future value. Or if I type FV, the inputs are rate, number of periods, payment, PV. And then I can also do PMT. So the cool thing about Excel is that the functions and the inputs are the same name. So NPR is an input to rate, it's an input to payment, it's an input to PV, it's an input to future value. But it's also a function. Payment is an input to rate, payment's an input to NPER, payment's an input to PV, and input to FE, but it's also a function. That's what makes Excel so cool. Okay, so in our first problem here, the situation is that you are considering purchasing a 9% $1,000 bond. So the coupon rate is 9%. So let's down here, coupon rate is 9%. The face value is $1,000. Whoops. Change that to a number. The price of the bond in Part A is $898.56. The number of periods is 5 years. And so we have everything given to us. The coupon rate, 9%, face value $1,000. Number of years, number of periods is 5 years. I didn't tell you that it was compounded or payments are made monthly, semi-annually, quarterly, or annually. So if I don't give you annual, like I do down here, I give you annual, semi-annual, quarterly, and monthly. If I don't tell you that, just assume annual. So because it's annual, because they're annual payments, there's only 5 total payments because there's a payment every year. Now the only thing we need to know here is the payment. And the payment that you receive every year, the annual payment you receive, is 9% of the face value. That's your payment. Now we can type the rate. So we type equal rate, and then the first thing is the number of periods. So I'm going to scroll down to B4 because P4 is where the rate is in terms of percent. And the payment, now I paid this price, which is a negative, to receive this payment each year and that face value at the end of 5 years. So that and this are positives if I'm paying out this price. So what that means is B5 is going to be positive. The payment's got to be positive. The price, on the other hand, is negative because you're paying it out to buy the right to get this stream of payments. And then the final one is the face value. And we hit enter and we get 11.8%. Okay, so we want it to 2 decimal places, which is what we have. The word percent shows up here, so we only have to type 11.80. We hit enter and we check to see if we got it right. And we did. Okay, so the only difference between A and B is that the price went up to $1,073.41. So all we gotta do is change the price over here. And notice the rate goes down. So what this tells us is that when the price goes up, yields go down. So there's an inverse relationship between interest rates and the prices of bonds. So we got those two right. Now I'm flipping the problem. Now I'm giving you the yield to maturity. So I'm giving you the rate. This is the rate as a percent. And I want you to calculate the price. And the price is just the present value of the stream of payments. 5 annual $90 payments and 1 payment at the end of 5 years of $1,000. You have a stream of payments here. The price of the bond is just the present value of that income stream. So here I'm giving you the rate. So instead of typing in the rate, or instead of using a formula to calculate the rate, I'm gonna type in the rate, and the rate is 10.6%. 10.6. Whoop. Gotta change that. Just a number. Okay, so the rate is 10.6. It's assumed to be in percentages. And what we want to know is the price or present value of this income stream. So I'm gonna make that bold, and I'm going to replace this with equal PV. And the first thing is the rate. So I'm going to go up to the 10.6, comma, the number of periods, comma, the payment is $90, comma, and the face value is $1,000. And then I'm going to hit enter. Okay, we have to convert it into a percent. Okay, it has to be entered as a percentage. Okay, so 10.6%, 5 periods, $90 annual payment we're receiving every year for 5 years, and then at the end of 5 years we receive $1,000. So the parentheses red means it's negative. So we can make that, we can put a negative sign in front of the PV, and it comes out as just in dollars. So the price, we pay out $940.27 to get the right to purchase this income stream if the interest rate is 10.6%. Oh, we don't need the dollar sign. Sorry about that. There we go. Now the one difference between C and D is the interest rate. So we're going to change the interest rate to 6.4%. And the price went up, so that when the yield maturity goes down, the price goes up. We're going to copy that and put it into my open math, get rid of the comma and the dollar sign, and hit enter. Okay, so the moral of this story is, as the price goes up, the interest rates go down. As interest rates go up, the prices of the bonds go up. As interest rates go down, the price of the bonds go up. The price of the bond goes up. Okay, now in the next scenario, you're considering a 9-year, 7% $1,000 bond. If the interest rates are 4.8%, so we're going to hold the interest rates constant at 4.8%, and then we're going to allow the number of periods to increase. So in part A, we have 7 annual payments. We have 7 year of biannual payments. So that 9 years of 2 payments a year. So 9 times 2 is 18 payments. And then we have 4 payments per year over 9 years. or 36, and then we have 9 times 12 payments. Okay, so what we're doing is allowing the number of payments to go from 1 per year to 12 per year. Okay, and then everything else is being held constant. We want to see what happens to the price of the bond. Okay, so interest rates are 4.8%. I'll go down here and put years, number of years. We'll just do num of years, right? Number of years is 9. And then payments per year. In the first scenario, we have 1 annual payment. We have 1 payment per year. Okay? So let's just start with the bottom. Suppose there's 12 monthly payments per year, right? The number of periods would be 9 years times 12 payments per year. So 108 total payments. And you can think of this as a loan, a car loan, right? A car loan, you got to make a monthly payment every month for the length of the loan, right? So this would be the number of payments that you made to the bank. If it was a quarterly bond, there'd be 4 payments per year and 36 total payments, because 4 times 9 is 36. If you got 2 payments a year, because it's semi-annual bond, you only get 18 payments. And if it's, of course, 1 payment per year, you only get 9 payments. Okay, so that's how that works. Okay, another thing we have to do is the coupon rate is 7%. So we got to figure out the coupon. So the coupon rate is 7%. 9 years, 1, and then 1,000. The annual payment is $70. But this $70 payment is being spread out over the course of the number of payments. So what we have to do here is we have to divide this by the number of payments per year. In this case, 1, right? So if we have an annual bond, here, because the coupon rate is 7%, and 7% of 1,000 is $70, we get 1 payment a year of $70. Now, if we got this semi-annually, once every 6 months, the $70 payment would be $35, and the number of periods would balloon up to 18. If we got quarterly payments, that $70 payment would be divided by 4. So 70 divided by 4 is 17.5, and we get, let me do this to help you out. Let's multiply these two together, right? We'll start back at 1. So if I multiply 70 times 9, I get $630 in payments, right? So total payments is $630. I'm getting $70 every year for 9 years. If that $70 is spread over 2 payments in a given year, the number of payments doubles and the payment itself halves, but the total payments is still $630. If I get that $70 spread over 4 quarters a year, the $70 is divided by 4. The number of periods goes from 9 to 36, but the total payment is still $630. And then if I get that $70 spread over 12 months a year, we're down to $5.83 a month for 108 months, and the total of those the total of payments is $630. So let's go ahead and reset this to 1. Okay, and just double check that we have everything. The interest rates are 4.8%. 9 years, 7% coupon, $1,000 bond. That's the face value. And annual. So payments per year is 1. Okay, so what is the price of the bond? Remember, the price of the bond is what? B3 is the rate. Oh, sorry. The interest rate has to be divided by the number of payments per year too. So we're going to divide that by 1. in this case. So this is the periodic rate. You can think of this as the periodic rate. There's one period per year. So this is the annual periodic rate. If we're getting payments twice a year, the interest rate is halved. Okay, just like the payment. If we're getting payments 4 times a year in a quarterly bond, then the interest rate's divided by 4. And then if we get monthly payments, the interest rate's divided by 12. Okay? So this is a monthly rate. This is a quarterly rate. This is a semi-annual interest rate. And this is the annual interest rate. Okay, and that makes sense because if we multiply this by 12, right? Obviously, we get 4.8%, right? Okay, so this is the total payments. This is the monthly interest rate. Our first one is a annual bond, so this is an annual interest rate. So let's go back to our present value calculation. Remember, the present value is the price because we want to know what the present value of these 9 payments, annual payments a year, and this payment in 1,000 years. So the price is the present value. Okay, again, remember we made it negative, right? And the first thing is the rate, in this case the annual percentage interest rate. The next thing is the number of periods. 9 times 1 is 9. And then the payment is 70. That's the annual payment. And then the future value is 1,000. So we hit enter, and we get that price. I'm going to just change it to a number with 2 decimal places, so I don't have to delete dollar signs anymore, because dollars is already here. And we hit enter to see if we got it right, and we do. Okay, now in this one we're going to change the payments per year to 2. So that doubles our number of periods. It halves our interest rate and halves the annual payment to the payment to 35. And the price, what happened to the price? Again, the price is, in this case, the semi-annual interest rate. The number of payments, in this case 18, because we have 9 years, 2 payments per year. And then we have a semi-annual payment of $35. And then we have a $1,000 face value. So what happened to the price of this as we increase the number of payments per year? The price goes up. Okay. Okay, now let's change it to 4 payments per year, because now we're talking about a quarterly, right? A quarterly. So when we type in 4 here, the $70 annual payment is cut in 4s, 17.5, 17.5, 17.5, and 17.5. The number of periods goes from 9 years to 36 payments. 9 payments to 36 payments, multiplied by 4. And the rate goes from 4.8 down to 1.2 because we're dividing 4.8 by 4. And the price is $11.60. Oop. And again, the price goes up a little, even more, right? So what is it saying? You're willing to pay a little bit of a premium for this bond. The more payments, the more the payments are spread out throughout the year, right? And then monthly, we change this to 12 down here. The annual interest rate is divided into 12. The number of periods balloons up to 108, and the monthly payment is down to 5.833% or dollars, and the price rises by a few pennies. So you can think of this these differences here and here as the premium you're willing to pay to spread those payments out over twice a year instead of once a year. You can think of this difference as the premium you're willing to pay to spread the annual payment out across 4 periods. And this difference you can think of as the price you're willing to pay to convert an annual loan into a monthly loan, if you will, or an annual bond into a monthly bond, to receive those payments per month instead of per year. Okay, now you are considering, in scenario 3, a 5-year. So we're going to change this to 5-year. 5-year. And it's an 8% coupon rate. It's a $1,000 bond. And the price is given. $950.93. Okay, the face value is 1,000. We'll reset this to 1. And we need to know the interest rate, right? So we're going to make this bold and then type equal rate, because we want to know the interest rate now. Because I'm asking for the annual yield, annual interest rate in percent. Okay, so here we're holding constant the price, the face value, the coupon percent, and the years to maturity. What we're changing is the number of payments made per year from 1 to 2 to 4 to 12. Okay. So here the rate is equal to the first thing being the number of periods. It's a 5-year bond with 1 payment per year. The next thing is the payment. The coupon percentage is 8%. 8% of 1,000 is 80, and we get that paid once a year. And then the next thing is the price, or present value. Again, we got to make that negative, right? Because we're paying this price for the right to get the 5 $80 annual payments and the $1,000 payment at the end of 5 years. So we're going to make the price negative. And then the future value. And we hit enter, and we get 9.27%. And because the word percent is here, all we have to do is type 9.27. Okay. Next, we're going to increase the number of payments. Oh, sorry. Remember what we did on the previous scenario? We divided the rate. Well, this rate is the annual payment, right? So what happens when, I'll show you that in a second. So let's do 2 payments per year, right? Notice that this was about halved. So this is the 6-month interest rate, right? We need to multiply that by 2 to get an annual interest rate, 9.25. And it's close to 9.27, right? So this would be what we get every 6 months. This is what if we get every year. This is what we get every year. Okay, so 9.25%. Okay. Now, instead of typing times 2 there, I'm going to highlight the 2 and then click on the 2 down here. Okay. So rate gives us the interest rate of a bond given how many periods we receive payments within a year. So in order to make that annual, you have to multiply by the number of payments per year. I hope that makes sense. Okay, so notice our $80 payment is down to 40, and our number of periods is up to 10 because we get 2 payments per year, and there's 5 years. Okay. And we're holding the price constant, $950.93. Okay, what happens when there's 4 payments per year? I'll delete the multiply by 4. So each quarter we get 2.31%. If we annualize this by multiplying by 4, we get 9.24%. Notice the yield is falling. That's because the price is rising, right? where prices and yields or interest rates are inversely related. Okay, now let's go to the monthly payments. Okay, so 8% of 1,000 is 80. 80 divided by 12 is $6.67 per month. The number of periods is 60 because 5 years, 12 payments per year. The monthly interest rate is 0.77%. The annual interest rate is 9.23%. So the insight here is that as the number of payments per period goes up, per year goes up, the yield to maturity goes down and the prices rise. Okay? And the reason why that is because, I mean, think about it. If you have to wait a whole year for a $70 payment, would you be willing to pay a slightly higher price to get half that 6 months earlier? I think so, right? So you'd be willing to pay a higher price, slightly higher price on the bond. If it's an identical bond, you'd be willing to pay a slightly higher price, almost $2, maybe $1.50. You'd be willing to pay $1.50 more to do what? To get $35 in 6 months and the other $35 at the end of 12 months, as opposed to just getting $70 at the end of the year. So this makes sense that the price would rise. And because prices and interest rates are inversely related, as the price rises, the yield maturity falls. Okay? And that's homework 3A question 1.